Hello there. Today we are going to do another problem using electric field, just one electric field, point charges. Before we discuss more abstract concepts associated with electric field. So in a previous video, we did electric field of these three charges at the corner of the rectangle, that point P. Okay. In that video, we had labeled this as D. We labeled this as D and labeled this as C in that video. But now I'm going to label this as C and label this at point P. Point P, you can place charges on it and ask questions like what's the force on that charge. But right now, point P is just a point in space. Now, in that problem, we found the electric field was this, and this is unit vector. This magnitude is 1. It's just used for giving direction, and that's the direction in that direction, unit vector. So electric field is a vector, and it's got this magnitude and direction given by this unit vector. And this unit vector you can actually see because the angle was found to be 67 degrees. The way we found this in the other example was this was just equal to electric field by this charge A at P, I guess, right? It's electric field at P by charge B, and then this, the third charge, plus electric field at P by C. Those three charges, a charge that's, if you locate there, you do not use electric field of that charge at its own point because it's not well defined. And each one of them, so this, if you look at the formula for this, is just K Q of A divided by the distance squared from A. So the distance between A and P, and then unit vector that's in this direction from A to P. A to P unit vector. So if this was positive, it's pointing that way. If this is negative, it's pointing in the opposite direction, A to P direction. This is unit vector. And so this just, and similar one for this and similar one for this. And because this is a vector, you can add up vectorially. And that's how this answer was obtained. You may want to redo it and see if the answer is correct. But suppose this answer is correct. The question is, rather than having these three charges, there will be some charge here I can place, a single charge. This is a single charge, a single source charge. What single source charge play on the x-axis that will have the same electric field. So because the electric field is pointed this way, and maybe you should place the charge over here because from the way the direction works, right? And so this will be a charge I place here, some point, and if this is sufficient charge, then electric field from this would be this way if this is a negative charge. So it should be negative charge because the electric field at P is pointing towards the source charge. This is the source charge. Remember source and target, or source and test. So you recall naming a vocabulary, naming charges, two types: source charges and field charges. Field charge, which is also called in textbooks test charge, or you might call it target charge So these are the common names, and if you want to call it some other name, that's fine. But this is a chart whose on which you want to find the force. But right now I don't have a target charge. There's no target charge. I know test charge. It's just I know the field that this source charge will, and so we need to figure out this, how much I need. Okay, let's see. I need on x-axis, I need in this direction, and this is 3 centimeter, and this angle from here is just 23 degrees, right? So I can just get this distance, and if I subtract from 4 centimeter, I'm going to get a x. This will be the x. X will be 4 centimeter minus 3 centimeter. If you look at this triangle, this is 90 degrees. So this is base, and this angle is theta. So this will be like a P over B equals tangent theta. So this is 3 centimeter tangent 23 degrees. Okay. So that's the X for this. And I really don't need the X, I just need this. So I just need this distance, and this is 3 centimeters. So the net distance here, the D, or let's call it little r from ABC. Let's call it G, maybe from G to P. Okay, so we want R from G, the charge from P, that will just be a square root of 3 centimeter tangent 23 degrees square plus 3 centimeter square, right? That's where it's going to be. And you can say this is 3 centimeter, and the whole thing will be secant 23 degrees. It's going to be square root of tangent square theta plus 1. That's going to be 1 over cosine theta, which is secant theta from here. Okay, so we got this guy, we got this guy. We need to have unit. Do we need a unit vector? Actually, to answer this question, we really don't need the unit vector. We want equals to the k of minus q absolute value over RGP square, and the unit vector that we want in this direction is just going to be 1. So we really don't need to solve this problem, as this one is given over here. So this is 2.8 times 10 to the power minus 7 plus 7 actually Newton over Coulomb, and K is 9 times 10 to the power 9. Q is what we want. Minus will become plus from using absolute value, and RGP square will be this square. 3 centimeter will be 9 times 10 to the power 4 meter square times sec square 23 degrees, which we can write down as cosine square 23 degrees, and then we solve for Q. Solving for Q, we find Q is equal to 2.8 times 10 to the power 7 times 9 times 10 to the power minus 4 over 9 times 10 to the power 9 times cosine square 23 degrees. So now we just numerically find out the answer. Okay. So for calculation, I find 3.3 times. So this is equal to 3.3 times 10 to the minus 6 coulomb, which is 3.3 microcoulomb. So if I place this charge over here, it will be negative charge. So if I place this charge over here, it will have, at this point, it's going to have same electric field as those produced by those three charges. So upshot of this problem is, if I just have information about this point in space by placing a charge there and experience the force on the charge, I can't tell the difference if the electric field was produced by these three charges or just produced by one single charge. So electric field at a point as experienced by a charge placed at that point, doesn't care how the electric field was produced. So in a sense, the electric field by source charges are they have a life of their own. Electric field does not care about how it was produced, which was the source charge. Were the source charges these guys, or source charge was just this guy? And that's a very important observation. Electric field has a life of its own. And we are going to discuss more about electric field in the next video. Okay, talk to you. Bye.